connecting the dots, speaking about production engineering at Facebook. It's going to be a slight change of plans. We have a logistics issue. We're basically trying to locate our Docker. So we're going to swap. I'm going to do today what I was expecting to do on Thursday, and then Espen will be taking over my slot on Thursday. So I apologize for that. This means that I haven't had too much time to rehearse this as I would have wanted to, but hell, we'll see what happens. So a couple of things. If you want to ask questions at any point, feel free, raise your hands, don't wait until the end. Okay? It's probably better if we just talk about things as they go. If you want to ask questions in Spanish, Catalan, Portuguese, Italian, feel free. I'll answer in English so that everybody understands. I can translate. Probably Italian will be much of a challenge. The rest of the languages is going to be okay. Oh, should I probably introduce myself a little bit better? I'm a manager in production engineering. I've been working at Facebook for 2 years and a half, almost, in Menlo Park in the US. Before that, I used to work here in Barcelona from 2002 until 2015. I worked 12 years at LifeCycle, a company that does electronic voting. So what I'll be talking about is this is a new presentation that we have never given anywhere that builds up from feedback that we got on these events. Sometimes when we go talk to events, people tell us, yeah, this is very curious, this is very nice, but how does this relate to my own work experience? Because we don't have that many servers or anything near that. So what we try to do here is I try to come up with a kind of concepts of how we evolved into where we are right now. What were the things that were identified as problems and how we changed to adapt to that. And at the end of the presentation, I will explain how is it that we build our automation today and what we think is the core concepts around it. Okay. So I will basically start by why. Okay. Typically, if you're in a small company, you have like what, 2, 3, couple servers, then you grow to 10, a dozen. So normally, infrastructure is not really something that you have in mind right away as you start building a company. Okay? First, if you're selling software, you will probably work on the software first. But then it gets to a point in which, as the infrastructure grows, you start having to pay attention because basically you cannot hire sufficient people to do that. Okay, this is the basic concept of why we automate server infrastructure. That's cool. Everybody knows that. But then it gets to a point in which it's so complex that you have to think out how to scale it. Yeah, one thing is, let's scale software. With a service, we add more hardware, and then we need to design the architecture of that software so that it scales with the load. But also, you have to scale the team, and not only the development team, but you also have to scale the DevOps team. So yes, when you start with a couple of chef cookbooks or a couple of bash scripts to configure your servers, that's fine. When you have hundreds of thousands of servers, you basically cannot have bash scripts for all of it. So we are going to explain how we work on this thing. Now, first, I want to describe a number of actors. So what is a service? A service is a piece of software that runs on a given hardware, with the peculiarity that normally the owner of the hardware is not necessarily the owner of the software. Then you have a server. Well, we all know what a server is. And then sitting on top of it, what we have is a service automation framework. Okay? This service automation framework is, again, it's another type of service. It's just that this service core business objective is to be able to handle the server lifecycle as automatically as possible. And then each of these layers is owned by a different person at Facebook. So you have service owners, the people that are working on the facebook.com that you see, that is conformed by hundreds of different smaller services. These are the guys that own this. Okay. Then the autonomous infrastructure team, this is the team that I manage. We build the framework so that we connect the guys in the data center with the guys running software on it. And finally, the DC Tech is the poor dude that has no clue of what's running in the software, in the hardware, and then when something breaks, they have to go and replace it and whatnot. So at Facebook, DC Tech, they really have zero visibility on what runs there. They have zero knowledge on the service. And so whenever something breaks, what you need to tell the DC technician is, go and change that part. They can't do any diagnosis, and they can't just be swapping parts just for the sake of it. So this raises a challenge, which is you have to be able to accurately determine when something's broken, what's causing the problem before you actually send a DC technician to change something. So in terms of lifecycle, I'm going to be basing it on this. So you have a server, you connect it, then you provision it. Should be using this, I guess. You provision the server. Now it's installed. It has an operating system, kernel, some firmware, some specific firmware you might need. We also install a number of core tools that every other services use. Then the next thing is, OK, now the server is installed. Now it's yours. Whoever service you're writing, you get all these machines. You have to get your software and put it in that server so that you can actually use it for something. And then you have the other part. It's in use. You have traffic. And this is where most of the automation stops in general cases. I mean, when you have a company that is of a normal size, normally you want to automate how you provision those servers, how you install them. But that's how far as you get. Then you just get alarms, and whenever there is an alarm, somebody goes and take a look at it. So here's how larger scale is significantly different. You just cannot decide, you cannot send, whenever you plug a server, you cannot send somebody to decide, now I have to run the installation on that server. Let's start the chef cookbook to install the operating system on that server. No, you have to detect that there is a new server there, put stuff on it. And then when the server is in use, it's running, if there is an alarm, well, if you have a couple thousand, if you have 100,000 servers running your service, if you're going to be called every time there is an alarm, you'll probably shoot yourself in 2 days. And so the logic here is how many alarms is really a problem? How do I fine-tune my alarms to only trigger when there is a really big problem? And hopefully how I can fix that problem without a human even knowing about it. And that's the part in which you came in with basically the repair and the remediation. Finally, the servers are physical things that live on a data center, and that lots of things can happen. I mean, to begin with, physical material, they have fatigue, they get damaged, so they have to be replaced, they have to be upgraded, have to be fixed. And so the server itself might be fine, but there might be a power line that has a problem, or maybe a top of rack that needs to be changed. A mouse ate the network cable, can happen. So when these things happen, you have to do some repairs. So the final step in automation that we're going to cover is how do you give tools for the guys in the data center to so you have the DC techs on one end, you have the service owner on one end, and so these guys, hey, I really need to stop all these racks to do something. You don't care, it's my problem, well, I'll do it, but I'm going to cut service from those racks. So I need to tell these guys that I'm going to do that so that they can react. And ideally, as again, you don't want to tell the guys, you want to tell the automation that these guys wrote so that it can react automatically. So when you start getting this big in terms of servers and team maintaining those servers, scaling that automation infrastructure, it really gets to be a complicated thing. So if you're growing as a company, if your infra is growing massively, so there are a number of axes in which, there are 3 axes basically in which you can decide to focus to improve your DevOps organization. Okay, when I say organization and tools that the DevOps support. So the first one to grow automation is by extending the covered lifecycle that you automate. As I was saying, first thing that everybody does, because it's a pain in the neck, is let's build automation to install the operating system. So we know that we want this specific installation of Linux with these decisions made, and so we create a script that you will get a new server, connect it, go run the script. The script will just run the standard Linux setup process. You will hard code some decisions, yes to this, no to that, whatever. Then you have a machine that has the system installed. And then hopefully you have some automation to install whatever software you have. I mean, if you're in Windows, you have the install package. If you are using some other thing, you may have Puppet, you may have Chef. There are a number of ways of provisioning those servers, installing the base software. So then this is like the easiest way to, or the first step, the obvious one that everybody takes towards automation, because it's initially the most time-consuming. When you become very good at provisioning servers and installing things, then most of your problems, most of your attention gets focused on running those servers. And again, typical thing, alarm, get a phone call. So another way of expanding your server automation is, okay, what about if instead of getting a phone call when I get an alarm, I try to fix it first. You know, the typical, hello IT, have you tried rebooting it? Well, you can basically automate the same thing. Your alarm, out of memory, maybe I should fix that memory leak, or maybe I can just reboot the server and move on with my life. It's an anti-pattern, but you can do that. So those sort of things. So you can implement a system to automatically react to alarms and do something. File system consistency errors on a server. You can implement automation that when you find that sort of error, you run a fixed disk and correct those problems. So you scale your automation by covering extra steps in that life cycle. So the second way in which you can do this is by adding autonomy into the software. And that's where things get a bit trickier, because if you have one problem in which the solution is pretty obvious and straightforward, you can code it. That's fine. In some cases, you have to have some decision making. You have to decide, okay, for example, there is an alarm in one server. And that alarm might be, I'm running out of disk space, and you know that by rebooting the server, you fix the disk space problem. So you reboot it. And then you have a primary database server and a slave database server, and the same disk space alarm gets triggered at the same time in both places. And so the remediations kick in. Oh, out of space, reboot, you're out of database, you're out of server. So there is services have operational constraints in which not all the servers are the same, and you cannot decide to do whatever random thing disregarding what's happening in other components. So that sort of decision making is where things get fun and get really complicated. Mostly because that decision-making process will never be equal for two services that you own. So if you're running software, if you're the DevOps team, and you are supporting different software engineering teams, one team may have one set of constraints, one decision-making process, another team might have another decision-making process, and then you end up with a huge if this service then do this, if that service then do that. And this is where the people axis can come. Of course, you have to grow your automation infrastructure. The first thing you have to do is please use source control for your scripts. That's obvious enough. Then you can have specialized teams to work on different parts of the automation, if you can afford it. And then there is two important things, which is the customized behaviors and the distributed ownership. And this is the way we do it at Facebook. So we have, for each service, we have a service automation package. It's basically a set of handlers that every team writes to implement their own part of the if. So they decide what they do, and it's on them to own it. So here's these two concepts. One is customized behavior. You have to have a framework that allows each different team to basically react in the way that their service needs to react. And the other one is you, as a DevOps team, there's no way you want to own all that. Because eventually it will get so complicated, nobody will be happy with any decision you make. Whatever you implement, you will say, well, okay, I'm handling this situation like this. And somebody will say, no, that's stupid. I don't need it like that. My server works in that way. So the better way to solve that is, okay, you do it in any way you want. I'll give you the framework. I'll make sure all the life cycle works. But there is a handler. The handler is your responsibility. And something that I did not mention, but it's always have a plan B. No matter how sophisticated your automation, sometimes it will not work. It will fail. It will do things that you did not expect it to do. So you always have to have an escalation. And here's the difference. Instead of just going to a human right from the start, you go to a human when your automation fails to fix the problem. So this is, well, I think I basically anticipated most of this. Here, the most of these things I just mentioned, customized behavior, distributed ownership, system runtime, you have to interact. So you have to give you have to give people a way to interact with the systems. So there is a problem in the hardware. You cannot expect, if you're going to give software engineering teams the ownership of fixing their problems in a handler, you also have to offer them a way to interact. Okay, what server is broken? How do you interact with that server? How do I reboot that server? So you have to provide them help for that. You can't expect them to solve it each on their own particular way, because then it's going to be a nightmare. So besides the framework that does all the logic coordination, we also offer an API for people to do things like send the server to repair or even reprovision it if necessary. And from all these things, the first three are pretty clear and pretty simple. The most complicated one is the last one. Just being able to identify all the decision making, all that tribal knowledge that people, I mean, when something breaks, people just know what to do. They go to the server, they connect. The first time you'll have to root cause. The 10th time that something happens, then people have information on their head on how to deal with that. Coding all that in software is very challenging. So how does it work at Facebook? So we have something like this. Starting from the center to the outside. So we have this part in light blue. These are Python classes written by every single service owner implementing their logic in whatever magic way they want. We help them, we can support them, but we don't care what they put there, in theory. The first two APIs that we give them is, of course, an automation API. This is the API that the interface that they have to implement for their handlers. And we give them an operations API. Just what I said before is how to access the monitoring API, how to power cycle the servers, how to create tickets in the repair system so that this can be done automatically and get whatever problem is routed to a DC technician. So on top of that, there is something called the automation frameworks. We have a number of tools for that. One is called Dapper. Dapper is a tool that allows the DC techs to enter a maintenance and saying, OK, from this day, from this time to this time, I'm going to be I'm going to be cutting power to all those racks. So then what the framework will do is it identifies what software is running on those racks, and it executes the automation from that software. And it basically tells them, OK, you know what, you are losing these servers for this amount of time, so what do we need to do about it? We have another tool which is called FBAR. FBAR is Facebook auto remediation. This is probably the most mature component of system lifecycle automation we have. FBAR is monitoring the alarm systems all the time. And you basically configure, if this alarm is triggering this server, then execute this Python handler. And then on top of that, we add some logics. For example, whenever an alarm is triggered, and FBAR, before kicking in, FBAR will suppress the alarms on those servers. Because normally an alarm doesn't come along. When an alarm triggers, it's because something's broken, and that triggers something else to break, that triggers another alarm. So you don't want to have lots of different code handlers executing on the same server at the same time. So what we do is we suppress alarms. The other thing that we do is rate limiting. As I was saying, if you have 10,000 servers, and for whatever reason you gotta have an alarm triggering 90% of those servers, and you remediate that alarm by, for example, let's say rebooting the server, well, you'll be rebooting 90% of your capacity at the same time. So we have this logic that is called rate limiting, where it prevents FBAR from hurting you. Basically, you tell him, OK, you can only do this number of times in this time window, and then FBAR will stop remediating until the threshold is down, and then it starts remediating more servers. All this thing runs on top of yet another component of the architecture. It's called FB Job Engine. This is a distributed long-running job, distributing a state machine for long-running jobs in Python. So if you are a service owner at Facebook, this is the code that you are expected to write. Now, a side note here is we do have a container system that is called Dapper. If you run on the container system, Dapper will handle all this for you. So it's not that everybody in Facebook has to write this, but some services that do not run on our container system, they really need to implement all this logic. If not, by default, they have this service in which they can be completely oblivious of all that. So they write their remediations, they write their handlers to drain servers, their handlers to make decisions for maintenances. Again, if you have to drain one server from traffic, that's not a really, at least it's like the only you have, unless you have a single point of failure in your infra, which you shouldn't, then draining a server is never a problem. So, draining a number of servers, that's when things get really, really sophisticated, and then we have like aggregate maintenance handlers. They get all the list of servers that are going to be drained, and they can look at that list and decide whether this can move on or not. Okay. And finally is the migration handlers. This is like the newest addition to the framework, to the infrastructure, which is basically the handlers to install software in a server or take it out. Yeah? There you go. So how do you, if you're a service owner, how do you implement this packet? Well, you extend a class, implement whatever logic you have, and you have here a couple of examples of the API. How do you run a piece of code in the remote, in the host that is failing? How do you reboot it? And then you clear the result. If the remediation succeeds, you clear. If not, you escalate, and then that's when your plan B comes in and people start getting phone calls. A maintenance handler is a bit more complicated. So you have, this is a very overly simplified version. There are like a dozen methods, but the general idea about this is, there is the pre-flight stage. In the pre-flight, we're going to ask you, hey, we need to drain all these servers from this time to this time. Can we do this? If you return false from the pre-flight, then the maintenance cannot happen. And then you go to plan B. Somebody has to change the maintenance to affect less servers or whatnot so that it can actually happen. Once you gave us the OK, once the pre-flight returned true, then when the maintenance, you will tell us how long it will take to drain those servers. And so we will take that time, and then we will back plan from the maintenance start time. And we will start executing your disable method when it's necessary. And then after the maintenance is done, we will call enable. And finally, we have the auto-remediation. The way it works is pretty straightforward. So you have an alarm raised. It decides, OK, this alarm in this specific server is mapped to this specific remediation class, when remediation is this. And so it will suppress alarms on the servers, apply rate limits, see that the rate limits are OK, and then execute the remediation code. If everything goes fine, clear or escalate. So how this works is pretty much like this. So you have a host. We have the alert manager system, detects problems, and raises the alarms. It's not that simple. So there is a number of ways in which you can raise alarms, okay, based on different aggregate data. I'm not going to cover that here. So we have the FBAR director. It's monitoring constantly for alarms. Whenever an alarm comes in, identifies if there is an associated remediation. If there is an associated remediation, it enqueues that in the FBJ queue. The job engine will pick the remediation from there and will run it. So this is not like just in time done. This is executed asynchronously. With this, 95%, this is old. I'm not sure what the stats are right now, but 94% of the alarms are clear without having to involve a human being, which is the goal. I mean, we really don't want, if we had to keep a high ratio of support people to servers, we would be broke probably. And we wouldn't be able to hire, and there's not that many people. And so as you see, many of them are just false alarms, and so they just go away. The other 40-something% is problems that we actually fix. Now, how does a maintenance work? Well, the logic is the same. The data center technician goes there, enters the maintenance, then we map, OK, we map what are the hosts that are affected by this maintenance, because, I mean, the DC tech doesn't know all the hosts. The hosts are lost. They will tell you, OK, I'm going to drain this row, I'm going to drain all these racks, or I'm going to drain all this entire data center. That, I mean, that's not desirable, it could happen. Then we execute the automated drain handlers. Okay? Then everything's clear. The data center guys, they go there, they do whatever magic they have to do, they change, they swap whatever they have to swap. Once it's done, we undrain, and hopefully things are back to normal. Now this, sometimes it happens, sometimes not. Sometimes it can be done without human intervention, sometimes not. Depending on, the more servers you include, the more likely you are to affect service operations logic and constraints, and then the more difficult it is. So the smaller the maintenance, the likelier that it will be managed on its own. And so the final piece and the component that we have is the job engine itself. What we do with this is we have basically a system of queue in which we have a number of machines. Actually, we run on top of the container, so we don't work with physical machines. We work with a number of entitlements. And so we have, but those entitlements they basically allow you to run, we run a shared pool and allows you to run your code in a distributed way. So if something fails, you can run in some other place. So this engine gives you a job queue. It gives you an API to implement your state transitions and to implement your behavior. It gives you a storage mechanism to persist your context between executions, because you basically have no guarantee that your code will be executed on the same machine. Each time you get a transition executed, it will run in a different place. So if you have to swap information up and down, then you need to use the context. And then it gives you a communication mechanism between the jobs. So we're running hundreds of millions of these every month. And it doesn't use really a lot of resources. We have I think our database is maybe 1 or 2 terabytes, and most of that is recent log information. Because we run on top of the container, we don't care about failing things, so we just run the job again. We try in a different one, which makes our life easier. And yeah, well, we process. I can't share specific numbers. This is as specific as our communications team will let me get. But as you see, it's pretty big in terms of the things it does, and we're probably using I think a dozen machines or something like that. Now, what are the key takeaways that you should take from this if you think about how you're going to scale your automation in the long run? So decoupled customized behavior is like the first one. If you are a centralized DevOps team, people will drive you crazy with their request, and everybody will want their specific, fancy, slightly different thing for them. So you can cope with that. You can owning everybody's snowflakiness. It's an impossible endeavor. In the long run, it's going to fail. So you want to separate that by decoupling the customized behavior first, and then hopefully making people own that. That's the second part is kind of a more challenging thing to achieve, because people will say, no, now you are the DevOps team, I don't care. But that's a battle that has to be fought in every single company or separately. But at least the first one, to keep all the customized behavior separated, it's like a no-brainer. Second is, if you want to scale your automation, don't focus on automating long processes. Yeah, we all automate installs because they take a lot of time. Responding to an alarm doesn't take time. One alarm. When you have 10,000 alarms, that's what they call death by 1,000 cuts. Small things that pile up to require lots of your time and make your life pretty miserable. Finally, this is like the latest stage, and this is the latest thing that we try to do at Facebook, which is automate as much of the decision-making as you can. This one, unfortunately, there's no recipe, and you don't always get it right. There's so much in terms of tribal knowledge and in terms of operational constraints that are not formally coded anywhere, that is a very difficult thing. So right now we are working on a system in which every service can implement their constraints, and then we can plan all these things based on those constraints. And finally, I have to do this. So we are hiring. We have production engineering offices in all these locations. So if you are interested, you have my Facebook profile there. Ping me, send me a friend request, and we can talk. And I think that's it. Yes. Questions? Nope. Do you have a mic for? Yeah. Thank you. Thanks.
Hello.
There you go.
You mentioned in one slide that you handle 100 false alerts in your automation system.
500, sorry.
Yes. 51%, sorry.
Yes.
51%, yeah.
Yeah.
So how do you avoid that these false alerts make you to perform a service down, for example, you know?
So one of the things is, what I'm saying about taking the service down, this is because it's a funnier IT crowd example of the guy that just tells you to reboot, but that's, we give teams the tool to do that if they have to, but that's not like the first thing we do. So you can write whatever Python code you want to do whatever you want in that server that's failing. You can run whatever shell script you want. So it's not like rebooting is the default. So in many cases, those remediations, they will go and check something. And when they see, okay, the alarm is cleared already, so I'm not doing anything. Or the alarm's still there, but yeah, we know this one. It's this other thing, and they just fix it. And a remediation kicking in does not necessarily mean losing server uptime.
Okay.
Any other question? By the way, as I said, if you feel more comfortable asking in Spanish or whatever, just feel free and I'll translate.
You're getting a lot of exercise. That's good. Okay, thanks for the talk. So the question is, how do you handle, the actual callbacks or, kind of snippets of Python crashing or not just finishing? When, when basically the customer's behavior, it's any piece of Python. It can crash, it can have an infinite loop, it can block. So how do you handle that?
So it's a handle that we execute if it fails or it gets stuck. There is no measure to prevent that. So basically, if the automation code is bad and it doesn't handle the exceptions properly, hey, your remediation will crash. Now, I think we run those remediations not completely isolated from each other. So there is a chance that if your code is crappy, that you will bring down a significant part of the system. So part of the things that we are going to be doing let me step back a little bit. So it used to be that all the different bundles from different services was packed in one mega thing. And so imagine, if you have a dependency of whatever login library version X, and some other dude decides to link this other incompatible version, then the remediation system cannot compile, or cannot be packaged, you cannot push it to production. Everything breaks. So the first thing we did is we tried to avoid that. Right now we have every handler is packed by service. So if you screw your own compile time thing, it's your own, and we are here to help, but it's basically your problem. Still, now everything runs together. And so, yeah, if you segfault, you will probably bring some other remediations, some other code down. I don't think we have that level of isolation so far. So one thing that we're trying to do is we have our two biggest customers are very clearly defined, are two specifically, and we're trying to build okay, here's a runtime engine for the one big customer, another runtime engine for the other one. So if you screw something, it's yourself, and then a smaller handler for everybody else. The idea is that you should not do that. I mean, you should have proper exception handler and do that. So something that we do at Facebook, this is a cultural thing. We rely a lot on engineers, and we trust them on taking the proper decisions. And then when we don't, we just try to understand what happened, and we find a fix so that it doesn't happen again.
Thank you.
Is somebody controlling time? Let me know if I have to stop.
Thank you. I would like to ask how you're managing resource planning in your company. Resource planning, for example, when you need more hardware.
Yep.
How you manage that situation between the different teams, because you have 3 levels: service owner.
So the way it works. So we are talking about a very, very high number of servers. So that's a very tricky decision. So there is a team which is called capacity engineering. Those guys are the guys that you have to go beg for hardware. And it's not like I need more hardware today. If you say, oh, I'm running out of hardware, give me more, they will tell you to fuck off, basically. You have to plan ahead. I mean, unless you have like a spike or a problem, we are flexible enough to accommodate those things, but in general, capacity will expect you to say, hey, I have this anticipated growth, and you plan ahead, mostly because capacity it's a very challenging thing to do. We don't have enough servers. So, sorry, we cannot putting servers online takes time. You have to have the space, the data centers, whatnot. And so yes, you will handle the organization with this team. They will plan the capacity in advance, and they will tell you what they can deliver and what not. Does it answer the question?
Yes, thank you.
Sure? I don't see you very convinced.
Hello. Hello all. Thanks for this topic. My question is about the percentage of fixes. Is it workaround fix or permanent fix so it will not repeat again?
So honestly, I can't tell. Because of the distributed model, I mean, I know that there are a number of service teams that they write the remediations. If the remediations are good to actually fix the problem, they are just a hack, we don't know. There is no metrics around that. Only the team owners do. One would think that they would try to get the proper thing done, because if not, the remediation will be, I mean, the problem will still kick in. But yes, I mean, I'm sure that there are cases of things that people should fix. Typical example is out of memory because of memory leaks. I'm not aware of anyone, but I'm sure that there must be some sort of that thing. Okay, I don't care. I know where the memory leak is. Fixing it is too complicated. Let's just reboot. Or things equivalent. Yeah, I'm sure there is things, but I really don't know how much of that we have.
Thank you.
Anyone else? Nope. Going once, go twice. So, thank you.